Now let's take a look at section 6.6. This is going to be on solving equations that use logs and use exponents. So we're going to be combining a whole bunch of things that we have done so far. So we have this equation we'd like to solve. 2 to the 4x plus 1 is equal to 3. Now, whenever we have an exponent that has a variable in it, so in this case, the variable x that's in the exponent, one of your first thoughts now of how you can solve this is to apply logs. We're going to use logarithms because they have a very special property that help when you have an exponent with a variable. So what's going to happen is I'm going to apply the logarithm to both sides. For me personally, I always use natural logs. Maybe if you've seen this in high school, they might say, pick a log with a special base. I just say use natural logarithms the whole time and you'll be good. So I'm going to take the natural log of both sides. So I have this natural log of both sides. Now, remember, we had a property about exponents inside logarithms. Remember, we said that if the whole inside was raised to an exponent, I could move that exponent down front. So what this becomes is I have 4x plus 1 times natural log of 2 is equal to natural log of 3. So this is good so far. This is good. Now, the reason this is good is because x was in the exponent. I had no ability to figure out what power of 2 do I raise it to get 3. I don't know how to do that. But here, now it is on the same level as everything else. So I just have x's times numbers plus other numbers is equal to a number. We know how to solve this. So I'm going to distribute this inside the parentheses. So I have 4 times natural log of 2 times x plus natural log of 2 is equal to natural log of 3. Now, these are just fancy numbers. Natural log of 2, natural log of 3, type it into your calculator, you get a number. But I'm going to keep those numbers around because we don't want to round those numbers. We're just going to keep those as natural logs. So the only thing left to do now is get the x's on one side and those without x's to the other side. So I'm going to subtract over natural log of 2, subtract over natural log of 2, and this gives me 4 times natural log of 2 times x is equal to natural log of 3 minus natural log of 2. So now to get x, to solve for x, I just simply divide by this number. This is just a number, that's all it is. An ugly looking number, but just a number. So I divide 4 times natural log of 2. I divide this by 4 times natural log of 2, and my answer is natural log of 3 minus natural log of 2 divided by 4 times natural log of 2. And there we go. That is your final answer to this question. So again, the important part is that when the variable is in the exponent, you're thinking in logarithms. So let's take a look at this one. This one has a little bit of a twist to it. Now I have 3 times e to the 0.5 times t is equal to 11. I'm trying to solve for t. If we try to apply log to both sides, so hypothetically speaking, if I try to apply log here, if I applied log, could I bring down the exponent now? Because that's what we did over here. I brought down the exponent, and that was awesome. But here, could I bring this down? Well, no, we cannot. The reason we can't, because remember, the rule said that the whole inside had to be raised to that exponent. Only e is raised to this exponent. 3 is not being raised to that exponent. Order of operations says I do exponent, then I do multiplication. So I cannot bring down the exponent. So I have to figure out what else can I do first. So the first thing I'm going to do is I'm going to divide both sides by 3. I have e to the 0.5t is equal to 11 thirds. Now this is the step we want to be at, because now I can apply logs to both sides. So now I can apply natural log of e to the 0.5t is equal to natural log of 11 divided by 3. Now I can bring down the exponent. I have 0.5t natural log of e is equal to natural log of 11 divided by 3. Now, natural log of e, you could plug that into your calculator, but this is a special one. Remember, log base b of b. So any base in which the inside is the same, this is equal to 1. So this thing right here is just equal to 1. So now I really have 0.5t is equal to that, so I just divide over the 0.5. Divide by 0.5, divide by 0.5. So this tells me t is my answer. That is natural log of 11 divided by 3 divided by 0.5. And that's it. So the important step that you want to take away from this is you must get the exponent by itself. Then take logs. Do not just immediately apply logs whenever. Get the exponent part by itself, then apply logs. That will allow you to bring down your exponent. So if we go here, if I divide this by 3, I approach this the same way. Now I have e to the 0.5t is equal to negative 11 over 3. Now, you could do the same thing that we did, right? We could go ahead and apply logs to both sides. Natural log of e to the 0.5t is equal to natural log of negative 11 over 3. But there's something very bad about this. Very bad. We had a rule about logarithms. The inside of a logarithm can never be negative. We are never allowed to have logarithm be negative. So if the inside of the log is a negative, that is a problem, and that means that this cannot be done. There's no solution. What this is saying here, we're saying e to some power is equal to negative 11 over 3. But we know e to any power is always something positive. We saw the graph of this, and this is going to be this. This is never a negative value. This is always a positive value. So here, there's no solutions. Or you could see here that I have a negative there. That's bad. There's no solution. So here, this is an example where there is no solution. So be careful. Sometimes you might not have negatives appear, and that's great. Keep solving it. Sometimes you might have a negative appear when you're about to take a log, and then that's when you say, nope, I'm done. No solutions.